Hello, my name is Chad Workman. I'm an instructor here at the University of Arkansas in the Electrical Engineering and Computer Science Department, and today I want to talk about digital memory, or more specifically, an SR latch. And it's a pretty simplistic circuit. It consists of two NOR gates connected in this feedback loop. The top one is feeding into the bottom input of the bottom one, and the bottom one is feeding into the bottom input of the top one. And before I talk too much more about the functionality of this circuit, I want to build it, well, more specifically, I have already built it, and I want to demonstrate how this circuit works. So let's turn it on and see what happens. Boop. Cool. The top LED turned on, so Q. I guess I should go ahead and talk about how this is connected up. This switch here is our S, so S is connected through here to the bottom NOR gate. This is a NOR gate chip. It has 4 NOR gates on it, so this is connected to here. This yellow wire is connected the output of the bottom NOR gate up to the top NOR gate. And speaking of the top NOR gate, this switch is our R connected to the input of our top NOR gate, and our output here, which is this LED, is Q, and our bottom LED is Q naught. So why did this LED turn on? Well, it's actually, it won a race. Let's show this here. This is the state our circuit is in. As you can see, this NOR gate, our top, our Q, is on 1, and this 1 is feeding back into our bottom NOR gate. NOR gates are only ever on if both of our inputs are 0, and since both S and R are 0, the only thing that's keeping this one on is that it turned on first. So this one turned on first, 1 got here, making sure that this NOR gate goes to 0, and this 0 is keeping this NOR gate off. So let's click some buttons and see what happens. Let's click this button. This is our set button. Nothing's happening. And this is our reset button. Boink. Our Q turned off and our Q not turned on. It essentially reset or set our Q to 0 and turned our Q naught to 1. And let's click set now. They go back and forth. Set turns on Q and reset turns off Q. You might be thinking, cool, but how is this actually happening? Whenever we are in this state here, let's say we click this button, we are clicking our set or reset button. We first turn on this, and we have our 1 still on, but now we need to look at our truth table, 1, 0. Whenever we have inputs 1, 0, our output of our NOR gate needs to turn to 0. So our next step, 0. Our output Q is 0, but now that we have an output of here is 0, it's writing a 0 back into this NOR gate. And if we have an input of 0 and 0, our output for this NOR gate should be 1. And that's the next step. Let's flip this over. Whee! Here, we have an input of 0 and 0, and our output of 1. This 1 feeds back into our NOR gate, so it holds this one at 0 even after I let go of the set. And I'll click here. So this operation is what I'm doing here. And it truly does go through each of these states. I click 1 here, this NOR gate turns off, and there's a brief instance where both of these LEDs are off, and then this writes a 1, or these double zeros make this be a 1. So now that I have this set to 1, I can let go, and this 1 holds this state. This is super helpful because we can use this to help remember what we've done. In normal combinational circuits, if you have, say, an input of 0, 1, 0, the output might always be 1 or might always be 0. With memory, we can remember what we've done before. This helps us set up things like conditional statements, if statements, for loops, allows our digital electronics to think instead of just doing a set output. This is kind of our steps from getting to digital electronics onto computers. And with that, thank you very much. I hope you learned something, and follow for more.